Hi, everyone. My name is Tom, and I'm a software engineer at Wix. And today I am here to talk to you about software engineering, philosophy, and the relationship between them. I'm going to present in this talk a few major philosophical theories, and I'm going to show some striking similarities between these theories and some modern software engineering practices that we all know and use. I will show you how you, in your everyday job as software engineers, actually participate in philosophical activity, whether you currently realize it or not. Before going into the depth of philosophy, I think I have to start this talk by addressing a question that's probably on a lot of people's minds. Software engineering and philosophy? How could these two fields even be related? They are something completely different, right? If you're anything like most of the people I've talked to about this talk, then you're probably wondering about this relationship. Now, before showing the similarities, I want to discuss why this relationship even seems so strange to us from the get-go. The main reason for this is that we all grew up in Western cultures. I don't know if all of us, but most of us probably. And in modern Western culture, it is common to dichotomize science from humanities and treat them as if they are mutually exclusive. Let's take a small poll. By a show of hands, how many people in this room identify themselves as scientific, analytical thinkers, problem solvers, mathematical? Okay, you can put your hand down. That's a lot of hands. How many people in this room identify themselves as artistic, expressive, abstract, emotional? You can put your hands down as well. How many of you raised your hands in both? Quite a few. This is interesting. Nice. It probably didn't take you a very long time to come up with the answer to this question, because the truth is that you've likely been asked it before in one form or another in your life. I know that I have been asked this question in many ways, many times throughout my life. And to be honest, personally, I've always kind of struggled with it. On the one hand, I studied philosophy and psychology, and I always loved poetry. So I guess that puts me on the humanities side. On the other hand, I always loved math, I taught chess, and I am a software engineer. So what am I? This question kept coming up, and that's because this division is really built into our culture, our language, and our social systems. One place in which we can see this division very clearly is in our education systems. All around the world, we are seeing educational programs of accelerated science, math, technology, and engineering. Now, these programs typically start from a very young age, and I think they are very good. They expose kids at a very young age to the wonders of science and allow them to expand their minds. This is great. However, an undesired side effect of such programs, which often goes away overlooked, is that kids are labeled. These programs are not for everyone. You are either in an accelerated math program or you're not. So the side effect of this is that kids are given a label. You are either mathematic, an engineer, or you are artistic, humanistic, not an engineer. The division does not really stop in the education field. We also have a bunch of pop culture myth around it. One common one, which I'm sure you're all familiar with, is the left side, right side myth. The myth says that people are born with a tendency or a strength in either their left or right hemisphere of their brain, quite similar to how people are born either right-handed or left-handed. The left hemisphere of the brain, says this myth, is in charge of language processing, mathematics, numbers. People who are left-brained are naturally good at these things. The right brain, on the other hand, is in charge of things like creativity, emotionalism, expressiveness. So people who have a strong right side are very good at those things. Scientific research in the past few years, using a lot of brain imaging technology, has shown us that actually, this myth is completely wrong. The brain does not work like this. It is not as clear-cut as we'd like to think. In fact, the left side of the brain does not have a monopoly on language processing. The right side of the brain does not have a monopoly on creativity. And in fact, most activities that we do in our everyday life are actually built on interconnections between the brain. Both hemispheres participate. It has also been disproved that people are born with a certain tendency or strength toward the right or left. In fact, as it turns out, most of us use both hemispheres quite equally throughout our lifetimes. Now, this begs an interesting question. If scientific research has disproved this myth, how come it's still around? How come it's still in our pop culture? We see it in magazines all the time. Are you right-brained or left-brained? How come many of us still believe it to this day? I think the reason for this is because as humans, we are very apt towards what is called binary thinking. It is very convenient for us to think about things as either black or white, good or bad, beautiful or ugly. When something is either or, my brain can decide very quickly and with very little information how to label something, and as soon as it is labeled, I don't need to think about it anymore. We do this all the time. Now, while cost-effectiveness is indeed a very nice feature of binary thinking, it also comes at a very big cost. We miss out on a lot of information. We become blindsided, and we distort reality, as is the case with this myth. Seymour Papert identified this division between science and humanities very well, and he even called it the great divide of our generation. Seymour Papert is the author of the programming language Logo. Papert observed kids and saw that many kids struggle with math due to what he believed was not a problem in math itself, but in the way it was taught. He wrote Logo in an attempt to help kids develop a more humanistic or humane relationship with mathematics. In the programming language Logo, there was a robot turtle with a pen connected to its belly. This robot turtle would be put on a piece of paper, and the kids would write code to move the turtle around. That way, kids would learn about triangles, circles, and the laws of geometry. Super cool way to learn math. Papert believed that the computer may serve as a force to break down the line between these two cultures, of the scientific and the humanistic. This talk is an attempt to follow his footsteps and continue this, breaking this line between these two cultures. Today, I am going to be focusing about the philosophical aspects of software engineering. Now, it's important for me to start by saying that I do not claim in this talk that a developer equals a philosopher. In fact, I want to say that participating in creating a piece of software from birth to maturity is a very diverse process, which requires the developer to do a lot of roles and context switching. In fact, you as developers need to sometimes be scientists, sometimes researchers, sometimes coders and engineers. Depending on the problem you are dealing with, you may need to be sometimes a mathematician. Depending on the team you're in, you may be required at times to be a mentor or a good listener. Sometimes you need to be a few of these things at the same time. It's a very, very diverse job. And for me personally, it's what makes it absolutely the best job in the world. Now, while each of these aspects is very interesting in its own right, today I will focus specifically on philosophy. Now let's take a look for a second at the development process. So the development process of, say, a new feature, a new product, always starts with a requirement. This requirement is always external. Traditionally, in the workplace, it usually probably comes from your product managers. Our job, to take this requirement and to turn it into a working software, code that is in production and does what we want to do. The million-dollar question is, where do you start? Now, this is a topic that there were books written about and blogs written about, and there's a lot of discussion. Let's say that we are out to build a Candy Crush game. Where do you start? Maybe you want to start by choosing the game engine or the animation framework. Maybe we should start by wiring the database or writing the front end or the back end or the build tool or CI. Where should we start? The truth is that none of these options is really very good. Rich Hickey, the author of the programming language Clojure, has a wonderful lecture with a brilliant title called Hammock-Driven Development. If you haven't checked it out, I highly recommend that you do. In this talk, Hickey suggests that the first thing you should do when you have a new feature is get up from the keyboard, go lie in a hammock, and think. Now, this is a really powerful insight. The truth is that no matter which way you go about it, I don't know if you're a hammock person or someone who likes to walk, or maybe you just call up a friend and start talking with them, the first thing that we need to do before we start actually writing code is to try and think about the problem that we have, break it down, and devise a plan. This is the process we call software design. The aim of software design is to solve a problem. Any good software design should answer a few very fundamental questions, such as, what entities exist in our system? What are their properties? What do they do? What is the relationship between them? And what is the correct way to use them? So we sit on a hammock and we start thinking about all these things. Now, it's important to say this list is not exhaustive. There are a bunch more things that software design should answer, but that's pretty much gives us the framework. Now let's take a look for a second at the philosophical process. And first, let's explain who is the philosopher. Now, I think a simple way to think about the philosopher is like an alien that landed suddenly from a faraway planet here in the streets of Barcelona. Where does this alien start? The British philosopher Bertrand Russell said that the natural starting point for every philosophy is to answer the following question: what are the world's furniture? What exists around us? And I think when you think about it, it's a pretty natural starting point. If you suddenly land here in the streets of Barcelona and you know nothing, the first thing you're going to try to do is probably you're going to try and figure out what in the world is the world. What is going on around me? This field of very fundamental questions like what exists, what is real, stuff like that, it's called metaphysics. Metaphysics deals with questions like these. What entities exist? What are their properties? What do they do? What is the relationship between them? What is the correct way to talk about them? And how did they come to be? Now, this list is also not exhaustive. There are many more things. So we can see that there are similarities between what the metaphysician asks when they do metaphysics and what the developer asks when they do software design. But there are also some key differences between them. The philosopher's scope is the external world. So if they landed here in Barcelona, their scope, their world is defined by where they are at. They need to explain this. The developer's scope is defined by the product, the requirement that was originally there. So if we're building a Candy Crush game, for example, we would not expect to have any entities in that product from the life of a blog, for example, or from the business logic of something else completely. This is the scope of the software. Another key difference is that while the philosopher asks questions about the world, so they are here in Barcelona and they need to explain what is here, the developer has an extra power. The developer gets to not only ask, but also they get to decide what the virtual world that they create is. That's why, in a way, I like to think about this part of software development as doing metaphysics with a bit of a superpower of creation. The developer gets to not only ask the questions, but also they get to decide what their world really behaves like. In either case, both of them need to provide answers, and the answers need to be coherent, logical, and consistent. So we see here that we ask pretty similar questions when we do metaphysics and when we do software design. Maybe an interesting next question is, do we answer them the same way? For that, let's take a look at an ancient philosophical problem and a few answers to it. This problem is called the problem of universals. This bottle, which I hold here in my hand, is what metaphysicians would call a particular. It exhibits certain qualities. It is round, it is half full, it is in my hand right now. I can imagine a bottle lacking some of these properties, like a bottle that is not round, or a bottle that is not in my hand. But I cannot imagine a bottle with no properties at all. Try it for a second. The way that we talk about particulars in our everyday life is as if, the way that we talk about properties in our everyday life is as if particulars share them. So we say that all of these are the same color. All of these are sandwiches. And all of these are chairs. When we say that, it's almost as if we are saying that there is something that exists in all of the items on the left, and they all share, but doesn't exist, for example, in all of the items in the center or on the right side of the screen. The problem of universal asks, what is this something? Do universals, do these things, redness, sandwichness, do they exist? And if so, what in the world are they? One answer to this is Plato's. Plato believed that yes, indeed, these things, these universals do exist in what Platonists would call the world of ideas. The world of ideas is an eternal, perfect world in which all of our ideas or forms or concepts live. Things like sandwichness, redness, humanness, chairness, all of these stuff exists in the world of ideas. Now, Plato believed that this world is a real world. Not only is it a real world, it is the real world. And in fact, Plato believed that everything that we see in the world, all of the particulars, exist only because of these ideas, these universals. So when we say in our everyday language that the two sandwiches share something, it's because in a very, very deep way, they do. They both realize, in a way, the sandwichness. They are not perfect, like sandwichness. These sandwiches can change, they can decay, they can be eaten, they can be thrown away. Sandwichness, on the other hand, is always there. Plato's idea can be summed up in the following points that I'll go over quickly. There exist ideas and things. Ideas are eternal, never change, perfect. Things can be created and destroyed. Things depend on ideas. In fact, ideas are the reasons for things. Ideas are models for things. So like we said, this sandwich, a specific sandwich, realizes the sandwichness. One idea can correspond to many things. Plato also believed that the ideas form a hierarchy between them and that there is exactly one idea which is at the top of the hierarchy. Now let's go take a trip in our time machine and skip about 2,500 years into the world of object-oriented programming paradigm. So, object-oriented is around the idea of objects that exhibit certain properties and behaviors. In the class-based version, which you're probably all familiar, objects are instantiated from a specific class. Many objects can be created from the same class. The objects are runtime structures. They can be created, destroyed, and altered at runtime. In many languages, like Java, C#, C++, classes are compile-time structure, meaning that by design, they are eternal. They cannot be altered at runtime. The classes inherit from superclasses, so they are also built in a hierarchy. Do you see the relation to Plato's ideas yet? If you're not completely sold yet, let me convince you even further. This is a reminder. This is Plato's 8 points that we saw before. Now let's observe what happens when you replace the word idea with class and thing with object. Let's see what that comes out to be. There exist classes and objects. Classes are eternal, like we said, in some languages at least, by design even. Objects can be created and destroyed. Objects depend on classes. Classes are models for objects. One class corresponds to many objects. The classes form a hierarchy, and there is exactly one class which is at the top of the hierarchy. Now, this should also ring a bell to many of you. Anyone who is familiar with Java, for example, knows that the ultimate superclass, the superclass of all classes in Java, is object, and it's in fact at the top of the hierarchy. This is incredible, right? I mean, look at these 8 points. I think they really describe well the class-based, object-oriented paradigm. Not even sure there is something missing here. The source to this 8-point comparison is a great article with a brilliant title, yet again, called Did Plato Foresee Object-Oriented Programming? By Tillman. Spoiler alert, if you go read this article, which I highly recommend that you do, Tillman's answer is no. Plato probably did not foresee object-oriented programming, nor does he claim, at least he wasn't able to find any specific evidence that Alan Kay was inspired directly by Plato when he thought about object-oriented programming. Now, I think that even if Plato's ideas did not directly inspire object-oriented programming, since it works so well, there is a question here we need to ask ourselves. Even if it didn't inspire it, could it have? And if it can, if it could have, and if it's that similar, could there be other ideas there in that area that we might be able to borrow and to take inspiration from to software engineering? Now, there were also those that looked at Plato's theory of ideas and were kind of confused. They were like, hey man, what in the world are you talking about? What are these crazy ideas? They are a perfect world, we cannot prove them, we cannot perceive them in any way. Who says they exist? Why do we need them? The nominalists believed that universals are not real, and that there are only objects. The French philosopher Peter Abelard believed that all that universals are abstractions. They are things that they are names that we give to things that we identify that are similar. We understand the similarities by observing some real-world objects, particulars. So when we say that 3 items are red, we are just saying that there are 3 items in this world that have something similar between them. They share something. But it's not a real thing. It's just an abstraction, a way of speaking. Amazingly, nominalism also has its object-oriented counterpart. Prototype-based object-oriented. In prototype-based object-oriented programming, there are no classes, only objects. Objects are created either by direct description, out of nothing, or by cloning, as if saying, I want something exactly like this. A prominent example of such a language is JavaScript. JavaScript shows us that it's actually possible to have an object-oriented approach even without classes. There is an important principle called Occam's razor, or the law of parsimony. It states that the simpler theory, the one that makes the least assumptions, the one that is most concise, is usually the correct one. Nominalists many times have used this principle in order to say, hey, our theory is superior. Drawing on the analogy, I guess we could say that maybe JavaScript can claim the same thing. Hey, we can do object-oriented without classes. This is superior. Does that really convince you to choose a prototype-based object-oriented language and not a class-based for your next project? I'll leave that choice up to you. So to recap where we're at so far. So we started the development process by going to lie in a hammock and thinking, basically. What's next? We have now some idea, at least a faint idea, of what we plan to do. The next step is also a very controversial thing that I'm not going to really want to go into right now. Do we start with test? Do we start with code? For this talk, I am just going to assume that you're doing TDD and that you're starting with testing. I don't think it really makes that big of a difference for this talk. So this is what a common test looks like. We start with a setup, we exercise, and we verify. So this is a test for a to-do list. So we initialize our to-do list, we instantiate it, we act on it by adding an item, and then we express some kind of expectation on it, which can be true or false. Keep that in mind. We'll get back to this test in a second. But first, I want to introduce you to the German engineer and philosopher Ludwig Wittgenstein. In 1921, Wittgenstein wrote the Tractatus Logico-Philosophicus. It is a book that dealt a lot with the relationship between the world, our language, and our thought. There is a bunch of interesting things around this area. Let's take a look at a few quotes from his book and see how they are related to testing and to software engineering. The world, says Wittgenstein, is the totality of facts, not of things. The logical picture of the facts is the thought. And propositions are truth functions. So let me explain these 3 sentences for a second, and I'll start with the bottom one. I think that's the easiest one to understand. Propositions are truth functions. So they are just sentences about the world which can be true or false. Sentences like, this bottle is round. The truthfulness or falsehood of these statements is determined by the correspondence of what I am saying with the real world. So I say this bottle is round, it checks out, it's really round, therefore it is true. If I said, for example, this button is rectangular, I would be saying something that is not true. So that is a proposition. Let's go to the second sentence. The logical picture of the facts is the thought. So Wittgenstein is trying to explain to us what a thought is by appealing to the idea of pictures. What is a picture? So let's start by thinking about a physical picture. A picture is just, says Wittgenstein, a model of reality. It's an organization of elements and facts in some kind of space. A physical image, let's say I would take your image right now, it would show us all of you people and the chairs and all of the furniture around us in a certain physical space. Similarly, a thought is a representation of facts and entities in a logical space. So this is the logical picture. Pictures, similarly to propositions, can be true or false, right? I can edit the picture with Photoshop, and I can have a thought which is not true. Like I can think that this bottle is rectangular. Finally, the world is the totality of facts, not of things. So what are facts? When I say that this bottle is round and it checks out, it's actually true. Then I can really say that I hold in my hand a fact. Wittgenstein thinks that if we knew all of the facts that there are to know about the world, imagine that just like I know that this bottle is round, I knew everything there is to know, every possible fact. If it was possible to know all of that, then I could say that I know truly everything there is to know about the world. Now back to the test that I showed you before. Let's take a look maybe at how Wittgenstein would look at a test like this. So in the setup phase, it's almost as if we are setting the stage for our picture. We initialize the entities around us in order to create the proper setting for the picture. We then act on them. In the verify stage, we actually just express a proposition, a sentence about the world, which can be true or false. Once this test actually passes, and we have a confirmation that, yeah, my expectation, my proposition is true, I can say that I hold in my hand a piece of fact about my software. Now remember, the world is the sum of all facts, not of things. I think if we apply this Wittgensteinian logic to testing, there is an important insight out there for us. We all might have a bunch of pictures in our minds of what our software behaves like, what it does under specific circumstances. But, as Wittgenstein tells us, until we have tested it, we don't really know. It can just be a fragile picture of what we think is reality. Imagine an ideal, fully tested software. Just like we said, knowing all of the facts in the world, imagine a software in which I know all of the facts. That would mean that I actually have tests for all of the possible permutations of state in my software. In such a software, I could say that as the developer, I actually know everything there is to know about my software. Perfect world. Unfortunately, software is limited, and it is not really possible to test all of the permutations of your code, of your software. What does that mean for us? What are the implications? They are quite high, I think. The implication is that if we only know as much as our tests tell us, that means that we need to test well. But we are also saying that we cannot test everything. So this leaves us with a big burden of responsibility. It is up to you guys, to us, to choose which facts are actually important in our software. Assuming you cannot know everything, what facts are important? A common advice is to follow the code path, and there are a lot of people saying that you should strive, for example, for perfect code coverage, checking that every line of code is actually tested. In my opinion, if we really take this insight that software is limited and that I cannot know everything, then you should ask yourself not what parts of the code are tested, but what scenarios, what product scenarios are really tested. What facts are important for your software? What facts are important for your customers? These are the facts you should be testing for. This is what you have to know about your software. Oh, sorry. Okay, so to recap, we started the development process by the fact that we have some requirement. We went to sit on a hammock. We got off. We started writing some tests. Now it's finally time to start writing some code. The code writing process, when you think about it, is really like any other piece of writing. Basically, the starting point is quite similar. It's a person sitting in front of a computer, usually with an empty text editor with a blinking cursor staring at them. And it's up to that person to use language to express some ideas in a meaningful way. I want to note here that code is always written in a specific programming language. Programming languages are important. We know that. The wonderful book, The Pragmatic Programmer, tells us this. And in tip number 8, they say that it's a good idea to learn at least one new language every year, as different languages solve the same problems in different ways. Wittgenstein would agree, but I think he would even take this a step further, as he says, the limits of my language mean the limits of my world. During my research for this talk, I was lucky to stumble upon the wonderful work of Harrison Ainsworth. Harrison Ainsworth saw a lot of relationship between software engineering and philosophy as well. And he wrote a full translation of Wittgenstein's Tractatus into software engineering world. It's a really fascinating read. He says, the limits of our programming languages mean the limit of our imagination. Try to think about that for a second. Let's maybe go back to Wittgenstein's triangle in order to understand it. So Wittgenstein says that the limits of my language are the limits of my world. Ainsworth said that the limits of my language are even the limits of my thoughts. If you don't believe them, let's try the following thought experimentation. Try to think now about something that you cannot express in words. It can be anything, a person, an object, a fact. Try to think about something that you cannot say in language. If you somehow manage to do this, please come after the talk and tell me about it. And of course, use your words when you tell me about it. So this is an interesting insight. And it also shows us how the pragmatic programmers are right. And yeah, learning new languages is not just a good idea. It's not just that they solve the same problems, but in fact, it's possible that there are problems that you don't even know of simply because you cannot express them at the moment. There are solutions around you that you don't know exist just because we have yet to learn the right language to express it. It's a powerful idea. Wittgenstein ends the Tractatus with this sentence. What can be said at all can be said clearly. And whereof one cannot speak, thereof one must be silent. Ainsworth adapted this sentence and said, what can be designed at all can be designed precisely. What is unknown, we must leave uncoded. Now, this is a sentence that I really wish that I managed to really take deep and never forget every day in my work. How many times have you ever tried to design for an unknown requirement? How many times did you write code that was good enough to solve the problem at hand? I don't know, the product manager was happy, but you just couldn't rest because you had this feeling that the next client that uses your code, they won't be happy. And that maybe in the future, we should do this, and we should do that. And your mind just couldn't rest because of this. How much time did you invest in it? I know this happens to me, to be honest, a lot. I really wish that I was able to follow the advice of Wittgenstein and Ainsworth and actually just not worry about these things. I would just add one thing here. It is not always easy to know the difference, especially from my experience if you have a very persuasive product manager around you. The limits between what is known and what is unknown is not always that easy to grasp. But once we do grasp it and we say, okay, this is the future, the best thing we can do is put it aside and just not think about it until we need to. All other stuff, everything that is inside our limits, that we can design precisely, and we should strive to, always. So let's summarize the journey that we took here today. So we took a bit of an unorthodox approach, a look at the development process, and saw it in a way like a philosophical development process. We saw how software design is pretty similar to metaphysics, but with creation powers. The developer gets to choose. We saw how texting is a way of expressing pictures and proposition and actually understanding facts about our software. We then wrote code and saw that when we write code, we solve a problem, but we are always within a certain limitation. Now, this line looks very nice and linear, but in fact, as all of you know, the process does not really look like this. It doesn't look like this in software, and it doesn't look like this in philosophy either. The truth is, the reality is that you start designing, you sit on a hammock, you have some idea of what you want to do, and then you start coding, and you find that something is missing. Your original abstraction was not good enough, and you go back to the drawing board or the hammock or whatever. The process is iterative in both development and philosophy. I hope that you are convinced after this talk that software engineering and philosophy indeed are not mutually exclusive. And in fact, there are a lot of similarities between them. We also saw in this talk, we took insights from ancient and 20th century philosophers, we took insights from them and applied it to software. We let Wittgenstein show us that software is limited by the languages that we use and by what we know. What is known can be designed precisely. Everything else we must leave uncoded. I also hope that this talk, in a way, has shown that inspiration to ideas in software engineering can come from a bunch of places. I really do believe that philosophy can be an interesting source of inspiration to ideas in software engineering. And who knows, maybe the next great idea will actually come from there. I want to thank you very much, and I hope you enjoyed. And if you're interested in talking to me about any of this stuff, feel free to reach out to me on Twitter or in my email, and I'll be happy to talk to you. Thank you very much.